Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and I'm joined as always by Nick, founder of Postgres AI. Hey Nick.
Well, Michael.
Hello, and we have a special guest today, Tudor Golubenco from Xata, CTO there. Really nice to have you, Tudor. Thanks for joining us.
Hi Michael, hi Nick, hi everyone. Thank you so much for having me.
It is our pleasure. So to kick us off, I wonder if you could give us a bit of the background story of Xata and take us through to where we are today.
Yeah, so I will actually start with what it is today, because we did change once, like a pivot or I call it more like a technical pivot. So it's a Postgres platform which has as differentiating features a very fast copy on write branching, so it can create a branching in a matter of seconds, even for databases that are terabytes in sizes, and scale to zero, which means that if a database is inactive, the compute part shuts down, and then on the next connection, it automatically wakes up. And this wake up is very fast. We're targeting 1 second. So that makes it very convenient, especially for developer workflows. So these non-production use cases, things like if you want a Postgres branch for each pull request, or if you want to create a sort of an ephemeral database for each agent run or for your agent and so on. These are our more common use cases. But on the Xata platform, we can and do run production workloads as well. So the differentiating features are on the developer experience if you want, but you can use it as a normal Postgres hosting provider as well. So that's what Xata is today. It didn't really start like that. The initial idea 5 years ago, my partner, Monica Sarbu, she wanted to do a database that's really easy to use. There was a lot of inspiration from Airbase or spreadsheets, and because they were like developer using Airbase as a database or Google Sheets as a database. So the initial idea was to make one that's as easy as to use as a spreadsheet, but that scales up so you don't have to switch at some point, so having features from both. And we did that for a while with some moderate success, but at some point we decided that it's pretty hard to build a long-term business on that audience, and then never really took off as a primary database for more production use as teams and things.
Apologies for interrupting, because you're packing a lot of stuff in a very short time. I just wanted to pause a little bit here, and this reminds me bit.io, right? They also like drag and drop CSV file. You don't think about schema or anything, but it's Postgres behind it. So you had a similar thing, right?
Yeah, but bit.io were actual Postgres. Ours, we were actually hiding Postgres behind our own APIs. So it was a REST API that you interacted with the data, a bit like Postgres or something like this. Nicer, I would say, but that type of interfaces. Yeah.
So I like this idea a lot, but bit.io was closed. I remember like a very short notice, like 2 weeks notice or something. People were like outraged. It was yet another, not fully Postgres platform, but I have something, I store my data somewhere, but then it's closed and I have very short notice to grab my data. And you are telling us right now that also this model didn't work well, right? In terms of...
Yeah, like there's definitely companies that address this sort of audience successfully. Like I'm thinking of Supabase, for example, right? But they have like millions of developers and such, and out of those millions, you're going to have a small minority that will become large databases, so they will pay a lot and so on, right? And we had a few tens of thousands. I think at the peak we had 50,000 users. Turns out of those, there's not enough paying customers to sustain such a business.
Thank you for sharing. This is super interesting. 50,000, that's actually a lot. But
it was quite a lot. We had the growth in the number of users, but that didn't reflect in the growth in revenue.
Many of them are not paying. Most of them are not paying. Yeah. I feel you well. I understand this problem also, like from all kinds of businesses. Yeah. It's hard to find business model on this. unless you're Supabase. This is a good comparison. Thank you so much. It's super. Like before this recording, I said we're going to focus on technical stuff, but the start is very different. But
Very busy.
I like it. Yeah, thank you so much.
I think it's really useful context to then dive into the technical side, because I remember one of your posts that I thought was really good about the architecture, which I guess might have been the architecture all along, but it explained how you could offer a free plan and how the free plan didn't actually cost you very much because of your architectural choices. And that was a really nice post from the business perspective, but also from a technical perspective, like understanding how those trade-offs actually help you as a business.
Yeah, so on the new platform, we don't have a free tier. This is, again, the business side and our experience with the old platform. So we call the old platform Xata Lite. It's now closed. We migrated the users that we could and so on, but it's now closed, so now it's only Xata. But the old platform had a free tier, and when doing the new platform, we were not very eager to add another one. Although with our current architecture, we can do it again, because we have this scale to zero, which is also very efficient from that point of view. But we're not very eager because it adds a lot of noise. And like I was saying earlier, you have some growth, but as long as if that doesn't really result in the type of business that you want, you get a bunch of feedback that's not really useful. And it confuses things a little bit more on the business side. We might come back to that decision, and maybe eventually we'll add again a free tier plan, but currently we don't have one.
Yeah, let's shift to more technical stuff, because I know you use cloud native PG, you have branching, you have very interesting open source tools like PG Stream developed and others like PG Roll, right? I'm very curious to talk with you about any of them.
Maybe we start at the Xata Store. It's our storage engine that makes a lot of this possible. And then we can go about how we use cloud native PG to get the very fast wake up times. That's also, I think, interesting.
So copy on write and branching.
Yeah, yeah. So we do copy on write branching, but we do it at the underlying volume level. So because our feature set is pretty similar with Neon, right? Also like copy on write branching and then scale to zero with fast wake up times, this sort of thing.
Storage and compute, right?
Yeah, the
And
decoupled storage.
And you recently made everything open source, Apache 2.0, or no? Or not,
not quite everything, but enough to run the whole platform yourself. But it won't scale to the same levels that we scale our own platform, and you won't get as fast times as with our platform. I can go into more details about exactly why. But we have open source enough to be running it yourself and to be useful, but it's not quite everything open source either. Yeah.
Cool. So if we talk about storage, like what's interesting there?
Yeah, so Xata Store, we call it like this, Xata Store, and this is like one of the proprietary pieces. And we have quite a long history into that. We tried a bunch of products and Kubernetes tools for managing storage, the storage layer. As in the end, we decided to build our own, but also use a bunch of ZFS functionality, so it's based on that. The way it works is, I'm not sure how familiar you are with ZFS.
Let me interrupt you here. My company, Postgres AI, has a database lab engine, which implemented database branching in 2019, before Neon and before Xata, right? And I have a lot of questions related to your experience with database branching and how you convince users that it's really needed, because we do it 7 years and some of them are solved very easily, but some of them still struggle and like, production data, we need to change it and so on. Let's talk about this separately, but I just to give you context that you probably don't have.
Yeah.
So, and it's on ZFS. Yeah.
Oh, are you using the ZFS? I thought you are using BTRFS.
No, it was not stable when we started, and I don't know if it's stable now. So yeah.
Okay, I was actually remembering wrong then.
It was actually interesting. When I created it first, it was came out of experience with GitLab. We just needed to give backend engineers capabilities to experiment and see, explain plans, not touching a few database experts, right? And it was great, it worked great, and then we scaled it. And the problem always was that, first of all, production data, how to protect this, right? And also, when Neon started working with branching, it's very different. So we do it very locally, and we achieve static cost for all clones and branches. So you pay once and you have everything like multi-tenancy in one virtual machine basically. You have very different model, so I'm very curious how it works and what do you observe, how people use it? And because my honest take, I spent a lot of time in this area. Market is still not understanding that branching is super powerful, and I hope AI will change. Yeah,
I think it's growing pretty nicely. But yeah, the use cases that we see most often are branch per PR. So they do PR and have some sort of preview environments. This could be like Vercel or their own stuff or different other platforms for ephemeral environments or preview environments. But then they want also the database to be part of that with the data, right? So then a platform like ours makes that possible. You have the database with the data. It doesn't have to be the exact production data. And the way we typically recommend people to do is we tell them, look, keep production where it is. Let's say it's RDS. And then this is why we develop pgstream. We create a replica of it, and the pgstream can copy the data once. So for small databases, we recommend people to set up a nightly job or a weekly job or something like this because it's simpler. For large databases, pgstream can also do the initial snapshot and then keep it up via a logical replication.
And DDL?
And DDL, yes.
And you solved DDL. I looked at it briefly, and I'm very curious, like how, if you do it, and what's your scale? Is it working really well? If it's working really well, why it doesn't go to core of Postgres in that form?
Yeah, I think there's some work in progress to make it in core.
There are several ways, and if you check recent, it's not It's not progressing.
Not progressing, yeah. Actually, a little bit of backstory on pgstream. We were doing in the old product, so Xata Lite, we were offering this REST API, and most of it was powered by Postgres. But we also had free text search with BM25 and relevance and so on. And that was actually served from Elasticsearch. So we wanted to have this replication between Postgres and Elasticsearch. And we could do, because we had like our own API for modifying the schema and such, you could do it in both at the same time. But that's also tricky because if you replicate data, but the schema changes come out of order, then again you have a problem because it's not going to fit the schema, the classical CDC type of problems, right? So it's actually better if the schema changes are in the same replication stream as the actual data. It's better that way. So that's why we did this event hook approach, listening for schema changes, and then apply them that. There, with Xata Lite, we had this advantage that you couldn't do arbitrary schemas in Postgres. It was a particular set of data types and so on. It was a little bit more into our control. So we knew we could test all possible schema changes and make sure they replicate correctly and these sort of things. But then we generalized this approach a little bit more.
Yeah, so that's interesting. So you have a limited set of what's happening, right? And then using event triggers.
Yeah, cool. Yeah, that's our approach. And of course, we need to make sure it's in the right place in the replication stream. And the way we do it is we write in a shadow table. We write what has changed and with what altered statement that happened, and that gets put into the logical replication stream. And then pgstream reads it from there and applies it on the target in the right order. That's the general approach.
I'm very curious at what scale it is working, and are you fully satisfied, or there are some plans to improve or something?
Yeah, we have people using pgstream at 4 or 5 terabytes of data, and the initial snapshot takes 24 hours or something like this. And then that depends on a number of factors or something like this. And then it's kept up to date. But then like it's from company to company, and sometimes we have to work on pgstream a little bit to make it work for them. But in the meantime, it had enough battles, let's say, that now we're feeling like it covers already the majority of cases, right? Pretty well.
Battle proven already, right?
Yeah, to some degree. Like there are still problems. This CDC logical replication is still quite a play. I would love if DDL would be supported in core.
Everyone waits for it, but it's super trivial, as I saw last time when I checked this topic. That's cool.
Yeah.
I like small non-technical side question. These pieces are, like you mentioned, some proprietary stuff, but pgrole and pgstream. And
these are fully open source.
Yeah, that's and Apache 2.0, right?
Yes. Yeah, and especially pgstream, it's important for us to be open source because we recommend people to run it in their environment because it also does anonymization. This is the, like kind of what we started from. It's important to do anonymization so that when you do this copy on write branching, the data is already anonymized and you have branches, very fast branches that don't contain the sensitive data. Like it's up to you what transformation rules you set and so on, but in many cases, like 80% of the data is fine as it is, and you have some data that it's sensitive and you need to transform it and make sure it's not in any developer copy and so on. And this, I think, is the perfect balance of things, if you want. But it does depend on this replication story. And we want to run it in their environment so they have full control over it. That's why it needs to be open source, really.
Yeah, this answers my question.
On the anonymization front, I saw you acquired a company. I saw some blog posts I think you wrote. Was it the beginning of this year? Is that what you've then rolled into this?
Yeah, partially. It's called Privacy Dynamics, this company, and they were like really deep into the anonymization front. It's like there's levels to this stuff. In pgstream, we already had the anonymization, which was simple column rule based. Like you can say, okay, this column, you can hash it like this deterministically, and it's hashed. But then, like for example, for HIPAA compliance and so on, you need to do the type of anonymization where if you, let's say there's patient's data and you have a woman that's 46 years old and so on, and has this email address or something like this, and if you just anonymize the email address, but it's the only woman in the data set with those characteristics, then you haven't really anonymized anything because you can, like even if the name is not there, there's enough information, unique information there that you can still work backwards what it is. So they're doing these sort of things where they see exactly combining the data set into groups and figuring out, okay, we need to anonymize this data so that no group is really small. Every group has more than 10 data points and such. So you cannot find the individual. And this is like more like HIPAA compliance sort of things and such. So that's also something that's not in pgstream at the moment. Maybe we will roll out more of those features in there. That we set up more like manually for customers that actually need this complex stuff.
Yeah, that's great. So these two pieces they're interesting themselves. So they could be separate episodes. This is what because if we dive deeper, there are so many levels. As I said, I'm in that space as well. We usually use some other tools, like we didn't build, and I remember also there was a company, Tonica. Yeah, I'm curious what happened to it.
Yeah.
Also,
they still exist, I think, right?
Yeah. So if you look to what they build, you understand that so many layers go there. Right? It's like
absolutely. Yes, and Tonic AI, I think they still exist, but it's just proprietary, and they open source like a simple version of it, but it doesn't scale at all. So
and important to also remember, like use cases are very different for branching. If you just want to, like you said, you don't recommend to take production, and if it's like simple development, it's better to have some like preview environments. It can be some synthetic data, for example, right? You don't need to synchronize it all. But if you bring data for a various like closer to production testing, and especially if it's related to performance testing, I was always concerned about what plans we will be getting. Because if you change data, I stop trusting those plans.
Yeah, of course.
So I usually try to convince people to keep like red data as is, production data, and just limit access and consider it as part of production and still have branching and test it closer to production. Because this is the only way you can have really realistic performance testing. What do you think about this?
Yeah, so there is this deterministic hashing, which basically means if you hash a value, it will always hash to the same thing, which is also useful for referential integrity. Let's say like if you have a foreign key on a string column or something like this, then you want it to anonymize the same in both places. So that helps a little bit with this. But yeah, with the Postgres planner, there can be a lot of nuances around it.
As I said, it could be a whole episode. If we dive deeper, like when you say hashing, okay, PG stream takes data from RDS, understand this. You have ability, like you copy anyway, right? But if you talk about your own platform, you have physical data directory.
You're right, yes. Yeah.
When you touch it, with any update, with anything, it's better, like we have thin cloning, branching on physical level. And if you start touching it, you already will. Michael will tell better what will happen with plans because he builds PGMaster, right? Which is focusing only on the plans. So if you physically change something, you like different number of blocks and so on, it's already different plans, right? Rel pages rel tuples numbers will become different. Statistics might start different. Even if you say update some row set column equals the same column ID something, logically nothing changed, but physically it changed, and eventually if you massive scale, it can drift plans.
Yeah, and logical replication already like kind of throws that away because it's going to.
But if we go back to ZFS and thin cloning, the copy and write, my point was always like let's not touch the data, and we will have ability to have the exact same.
Yeah, and you can still do that. You can have, like, if you run production on Xata, what we typically recommend is have prod projects and then something like a staging project or something like this, and pgstream between them to do the anonymization. But then the prod project still supports copy and write branching, and that would be like ZFS clone type of thing. And you can use that, but you would only use it when you actually need it for like performance.
Like I see Michael wants to ask something. I will ask very last question because I sit in this topic 7 years already. So I'm super curious to find guys who have like also spent time there. Last question from me: unit economics. If we want to build like pipelines which will test performance plans, right? If we keep data in Xata production and build these pipelines, will every CI pipeline lead to provisioning on the whole node? Will I be paying separately for if I run 10 pipelines or 100 pipelines? I need to pay for everyone, right?
Because we do this separation of storage and compute, right? And on the storage side, there's this thin copy, right? So you only pay for the difference. That's on the
so it basically doesn't change. If I don't change data, it's the same price. I don't pay.
With, of course, some gotchas there as well, but at the high level, let's say that. And on the compute side, we use Kubernetes, so that they will be starting on different compute nodes potentially, but not each new branch will be a new node necessarily, right? They will fill existing nodes and such. And there you only pay if you use our Xata cloud platform, because you also have bring your own cloud, which is a little bit different. But if you use our cloud platform, you only pay for the time the branch is active. And with this scale to zero, that like for development, it makes a lot of sense because it wakes up in a second when you connect to it, right? And you can set like a 5 minutes expiration time. This is like a lot of our customers do. It's like you pay almost nothing. I actually have a blog post. You can run 1,000, it's just how the math works. You can run 1,000 branches for $1, basically a tenth of a cent each, if they run for 5 minutes.
Yeah, that's great. So this is much better than what I observed with thin cloning in Aurora and Neon. Right? Because there is absolutely, it's linear scaling. If you want many pipelines in CI to test, you amplify your spending budgets. And this is super important because this makes engineers to stop testing enough and they start.
Yeah. And it discourages to have a branch for each PR, which is like.
Oh, kudos for that. This is cool. As I understand, it's not like a constant price, but definitely you thought about this, and because this is super important to make testing more like intensive and complete. That's cool.
Yeah, so definitely Neon, like you get 20 branches for free. You still pay the compute. They're not completely free. You pay for the compute, but above 20 branches, you pay a fixed amount for each of them, even if they are inactive. So we don't do that. We don't charge that. That's why you can have 1,000 branches with only $1, which, I don't know, maybe in a year we'll have another call and I will say that doesn't work economically.
You said there are nuances. I know exactly which nuance. If you have some branch or clone or like it holds snapshot, and if production runs away into the future, you start paying for all data to be stored, right?
Yeah, exactly. Or it's like it's sometimes hard to explain because you create a branch. Its cost is 0 on the storage, and then you delete all the data into it, and then you wouldn't expect the cost to go up, but that's actually what happens because now it's different from the parent, right? Yes. So it's like, hey, why am I paying more by deleting data, right? That can be confusing sometimes.
This is exactly what we also had and still having. Yeah, that's cool. Cool. Yeah. Yeah, Michael, I apologize. You had questions. I'm just
no.
Talk about this
I was gonna ask more, but actually now I'm thinking. I think this is great in terms of using Xata for your developer environments. Let's say like pre-production, those early maybe per agent, per branch, that kind of thing. But I think you've also got some interesting stuff on the developer experience of running Postgres in production, like PG role, for example. But I suspect you'll have opinions on a lot of the other things that are currently quite hard to do as a developer running Postgres in production. So I wondered about getting your opinion on some of those. So the big one for me, I think still that's difficult for people to manage is major version upgrades. Like that, like things like that. I wonder if you have any takes or any interesting features that most managed services don't offer, or things that you want to do in the future to make things like that easier.
Yeah, we did put a lot of effort into the schema changes. Part of it felt to us like one of the biggest pain points in Postgres. There's a lot of gotchas there as well. Like you do a schema change and it works on your small database that you test with, but then you run it in production and it locks the whole table for a long time. So then you have to do this process and orchestrate multiple PRs, change the application, do the backfill and so on. So that's how we started PG role. It's also related to the old platform, which again, it was all about making the database as easy as possible to use. So then we had an API to do schema changes, and that was we couldn't do as much as Postgres can do, but everything that you did there was guaranteed to be safe. You could never lock your database and such. But then again, you hit the problem that people want to do those things. So it's like that Postgres functionality was not added for nothing, and then you end up having to support everything, which was our problem. So yeah, PG role is like it's an attempt to make that as simple as possible. It's working. It also has some gotchas that currently we're not super focused on it because we're focused primarily on the Xata platform itself with copy and write branching and supporting many agents and these sort of things. That's where our focus is. So we didn't have that much time for PG role lately. Yeah, that's where we are.
So now focus is to give database to agents, right?
Right. And that can be in two ways. One is during development, like you give, like I was saying earlier, branches per PR. Now with agents, you create a lot more PRs, and we're seeing companies that have 2 engineers and they have 250 open PRs, and they're actually all making progress and such. We see people that don't do reviews. It's only AI reviews, and they get merged automatically. the tests are running. A lot of these things are happening now and will probably happen more, right? So that's one. And the second way is like AI platforms that need a Postgres database as part of their product, right? And then they want to spin up like an ephemeral database for that application, which could be an experiment that they throw away. So then you want these cheap databases that spin up and down very dynamically and scale a lot, scaling to many databases if you want.
Yeah, these guys even don't need HA at all, right? Just single node, no failover needed.
Yeah, exactly. Usually you don't need replicas for those use cases, yes.
Yeah, so no high availability needed, maybe just backups and that's it, right? Like you also feel this like new demand for
Yeah, and we do take advantage of that because the way we solve these very fast wake-up times is by doing what we call warm pools. We keep CNPG clusters ready to go. And then when there's a connection for a hibernated branch or database, we take one already provisioned clustered from the pool and we connect it to the right ZFS volume on the Xata store storage node and then serve it to the user. And that's how it happens so fast. But this means the clusters in the pool have to all look the same. Because if they don't look the same and they have different RAM and so on, that's obvious, but also different Postgres settings. If that causes a restart, then you did nothing because you need to restart it then too. So we take advantage of that. The cluster pools have no read replicas. They're very fast, but it is what it is.
How fast it is?
So like we're targeting a second. Provisioning a new cluster is the simplest operation because we just take one from the pool and give it. Also second. But it's that most of the cost there is really the control plane. We have a single global control plane region, so we have to go to it and so on. But that's fast. The wake up is actually more interesting because there you cannot just take one from the pool and serve it. You have to take one from the pool, connect it to the right volume, and then serve it, right? And this is what the Xata store enables, and this separation of storage and compute to some degree. And we have a bit of a trick that Cloud Native PG doesn't support any of this, so we are maintaining kind of our fork of it to enable some of that. But there's the instance manager in Cloud Native PG, and we modified it to essentially wait for the PG data folder to show up, and until then it's waiting. So the pod is completely provisioned, it's just waiting for that folder to show up before letting Postgres start. And behind the scenes we mount it in the right place, and as soon as that shows up there, the instance manager will let Postgres start. And Postgres starts in 300 milliseconds or so. It depends as well if the checkpoint was done and then things like this. But if it doesn't have to do the recovery, it's actually really fast. But what's expensive is provisioning the whole stuff in Kubernetes around it, the pod and the init containers and these sort of things. That's where the time was going. So that's why we do all that thing, and then the connection, the work that we do at the connection time is actually minimal. That's why it's so fast.
That's impressive. That's cool. I have a tricky question. Oh, okay. Michael first.
I maybe have the same tricky question. I wondered about you're in a development environment. You probably want the same extensions as production, or you might need them in order to test various things, and also you might have changed a lot of configuration parameters. I'm wondering how. Maybe it's not quite relevant to the same pooling system, but does that system you just described limit your use of extensions and changing of configuration parameters?
I just want super user.
Okay. Two different questions. Let me start with the one from Michael. Yeah, it does, because the problem is you cannot keep a cluster pool. This is how we call them. You cannot keep a cluster pool for each combination of, like, you have instance size, and then you have a Postgres setting or list of extensions and so on. preload libraries is more relevant, because the extensions, they can be on the image. You just don't enable them or enable them. That's fine. That's not a problem. But if you need a different set of preload libraries, that is a problem. So we just chose to enable more common stuff in the preload libraries by default. And then you have to keep in mind that if you are not on the happy path and we don't have a cluster pool for you, it still works. It's just slower. It will take a few seconds then, 6 to 10 seconds instead of 1 if you're not on the happy path. And then the other thing is that we haven't done yet, but we want to do, which is auto-scaling for the cluster pools. Because some configurations, if you want, are going to be a lot more common than others, right? The default settings that we have, you would do a cluster pool of 100 waiting to go, right? So that you can do 100 at once and it's not overloaded. If you have a more complex one, it could be just one is enough, right? Because you start that one and then you immediately provision the replacement for it. That will take 10 seconds. As long as someone else doesn't do the same operation in those 10 seconds, you're okay. So it's enough to keep one around. But making this via static configuration, definitely annoying. So that's why we want to do some sort of auto-scaling based on that. So depending on the demand that we've seen historically, we would make these pools smaller or bigger, and that would automatically optimize costs for us. That's something that we haven't done yet, but want to look into it. Yeah, super user is I happen to know your opinion on that. We don't give super user to our user. We give
about it at least.
Yeah, the issue is because we run on Kubernetes, it's pretty hard to secure it at that level. If you can run copy program.
Let's wrap up this question. I have much more interesting and we don't have a lot of time. So question to you, tricky one. If you started this platform to build this once again right now from scratch, would you choose Kubernetes still?
We do use a lot of stuff from Kubernetes and it's good. Yeah, I'm happy with overall.
That's most important. Okay, cool.
Yeah,
Are you happy with Cloud Native PG?
It's that's more on the fence, I would say.
Do you know my opinion about it?
I know your opinion about it.
Yeah, and more is coming actually. Literally this weekend, I didn't work only on this PG SimCity. I worked on.
Oh, that's awesome, by the way.
Yeah, thank you. It was a simple one prompt. It was unexpected. But this thing, what's happening? We have a winning leader among Kubernetes operators, which is completely ignoring the facts about split brains and data loss and so on. Do you use synchronous application if you have multi-node setup?
It's configurable.
It's configurable, but it's not on by default, right? It's not on by default, and which means I have demonstration of split brain is still possible and in multiple ways.
Tudor, do you mean you let your users configure it?
Yeah, we can enable it for them.
And in Cloud Native, it's not enabled by default. It's configurable. It's the same. Yeah, that's the problem. And so, haven't you already maybe I'm over maybe we don't need proper HA, split braid protection, and so on. Maybe this is it's okay to run this thing. And if you don't know about your users suffering maybe at your scale, that this is good enough already, right? It's okay. What's your take on this?
No, I think it's definitely a problem that I'm also a little bit disappointed by the response to that issue. I was expecting to be closed sooner. I understand it's tricky because in CNPG there's no proxy layer. So they rely on Kubernetes services to expose things and to move them around. That makes it, I think, a little bit more complex for them compared to Patroni, for example. The funny thing is we do have a gateway.
It's not complex. It's impossible. It's impossible. There is no consensus algorithm used. There is only quorum. And there is mixing of concepts quorum is needed to handle transactions. It's not for deciding who is the primary. So I have demonstrations. You can have multiple. You have two primaries. You can have split brain. You can have data loss. and more to be published soon. I'm pissed off because of their popularity, clients keep asking us. I literally have right now 2 asks from 2 different companies to explain, should we use Cloud Native PG? Because it's super popular. And now, like, I meet you, and you use it at scale. So you don't have problems with nobody lost data, nobody dealt with split brains. Do we have, maybe we have already good cloud resources which don't experience like outages, like maybe this is it. Maybe we don't need the HA replicas, maybe even, right? Like it's already good enough to live with a single node. So there's no such a problem as HA, high availability, no more such problems. Or you had such issues like split brains or data losses because there's no consensus algorithm.
Yeah, it's, I would have to go back and look how often. Like I do remember maybe one case where, to be honest, we couldn't figure out exactly what happened. In these things, there's always a combination of factors. But I do remember once we thought like this might actually be the split brain scenario hitting us. So like I think it's a bug really.
Unfortunately, in their DNA, it's like this is a basic decision. If you read the recent post, I have an answer unpublished. I'm going to publish it, so more stuff is coming.
It's coming.
And I sent you a LinkedIn request. Please accept it. Let's talk. Let's keep in touch on this topic because I want the industry to understand that consensus algorithm is needed, and either Cloud Native PG needs to change, or people should stop using it. Or maybe we like one node is enough. We don't need HA. Everything is good. AWS and Google Cloud, they stopped being unreliable as it was 10 to 15 years ago.
Yeah, on our side, I told you, we are on a fork of it. It's not that I would not recommend people to use our fork because it's open source as well, but we didn't make it with the goal of becoming like a CNPG successor or anything like that. But we did go a bit in a different direction when it comes to backups. For example, we're using PG backrest and we made it in the operator itself rather than the plugin solution, which has a number of disadvantages. So we have the precedent of us going a little bit in different directions regarding these things. Also, we do have a gateway anyway. We need a gateway, like a SQL gateway. So then like the main benefit that you are proxyless actually doesn't really apply to us. So that might be also something that we would choose to do a little bit different there.
Yeah, and by default, Cloud Native PG has Barman or for backups or what?
It's a plugin. It used to be Barman in the core, but then now it's Barman as a plugin. Okay. I think as of right now, it's the only plugin that exists. I think there's a one for PG backrest, but
so if you replace and if you have PG backrest, this next step is just to add Patroni.
Yeah, you're right.
And when my concerns are fully resolved, I'm okay. Consensus algorithm works well and so on. But I understand it can be super challenging at your scale because if you have a lot of smaller clusters and so on, etcd or something, like you need to properly engineer it. I think it's done by some guys, but it's not straightforward. Because we don't, if we have a lot of small clusters, we cannot afford etcd for everyone, right? We need to have shared etcd, and there are some limitations.
Yeah, exactly.
But it's like it would be natural step. Like next time, you bump into a couple of other weird cases, and maybe you should add Patroni. Something like this.
Yeah. But there's the advantage that we don't really do this yet, but it does make sense to have a bit of different configuration for your development branches versus your production branches, because the thousands of branches and so on, the really large numbers, don't even have replicas like you're saying, because that the point is that you shut them down, they come back up. The storage is separated and it's secure no matter what. It doesn't depend on Postgres at all. So then you just don't use read replicas at all for those use cases. And the production ones are just much fewer, and then you can...
And computers smaller, right? So less, shared buffers is small, everything like this, right? But then you can fool the planner and make it work as to choose the same plans as in production. This is magic I realized some time ago, and it's super cool that you can have a tiny memory small, shared buffers is tiny, but you say effective cache size is huge, other planning parameters are huge, some other things, and you get exactly same plans as in production.
Oh, that's cool.
Yeah, and
I
then you
didn't
need to
realize.
just adjust. You need small mind shift and engineer minds to make them focus on buffers numbers more because timing might be different. This is what we talk about buffers 3 years already or 4 years.
Yeah.
Yeah.
I'm super conscious of time, but Tudor, is there any last things or shout outs you wanted to give on the Zeta side? Like, I'm very aware we haven't even talked about Delta X, which looks really
Yeah.
promising.
Maybe we do another one in a few.
Yeah, let's have part 2 quite soon. Yeah. It was cool, and thank you for coming. I enjoyed it a lot. I think we do similar things, like in terms of where we headed. I think everyone should use database branching. It's super cool. We will have all the links in show notes, right? And
Yeah.
so I encourage everyone to try out if you haven't. And I guess you just need to tell your agent to try to go and use it, right? That's it.
Yeah,
Super simple.
pretty much, yes.
That's cool. Thank you for coming. Let's have part 2.
Yeah, thanks so much, Tudor.
Thank you. It was really nice. Thanks, Bob.